Hey guys, Mr. Adamson here. Welcome to another lesson where we're going to identify ionic molecular compounds, write chemical formulas from word equations, balance, and identify types of reactions. So this example here, we have butane reacts with oxygen gas to produce carbon dioxide and liquid water. So the first thing I said that we're going to do, we're going to identify what we have and if it's an ionic compound or a molecular compound. So we can see we have butane, oxygen, carbon dioxide, and water. So the first one's butane. Butane would be most likely given to you, wouldn't be something you'd be expected to remember, but if you look it up, the formula for butane is C4H10. So butane C4H10. And butane is a hydrocarbon. Now we know that we have a carbon and a hydrogen, both are nonmetals. And therefore, if we have both nonmetals, we have two anions. We know from the naming rules that we are dealing with a molecular compound. So molecular. Next, we look at oxygen. And oxygen is just an element here. But when in a formula, it's going to be written by itself. And therefore, we know that oxygen is one of the diatomic elements. So oxygen will actually be written as O2. Then we look at carbon dioxide right here. Like carbon's a nonmetal or an anion. Oxygen or oxide is a nonmetal, so an anion. So we're dealing with molecular compound. This is where we go to using the Greek prefixes for naming, and we see that we have one carbon, so it's just C, and we have dioxide, which is 2, so we have CO2. Then the next one we go to is water. And it's pretty understood for most people that water is H2O. That is a non-IUPAC name, but it's H2O is identified as water. That's how you identify it. You wouldn't call it dihydrogen monoxide. H2O is known as water. And again, we have all nonmetals here, all nonmetals here. So we are again all three dealing with molecular compounds. So what we need to do now is write out all of these from this word equation and put them into an actual chemical equation where we can balance. So we have C4H10, so butane, oops, sorry, not a 2. So C4H10 reacts with, so reacts, knowing we have a plus sign, oxygen gas. Again, we talked about how oxygen is a diatomic element, so it would be O2, and butane is normally in gas state at room temperature. Oxygen, we're told already, it's a gas here. To produce, so arrow, so going from reactants to products down here. Carbon dioxide is a gas. And liquid water. Now, when you're doing balancing, what you want to do most of the time is when you have hydrocarbon here, so when you have carbons, hydrogens, and oxygens, you usually want to leave the H's and the O's till the end, so leave the O's till last. So we're going to balance the carbons first. So what we can see here on our reactant side is that we have right now 4 carbons. We go to our product side and we can see that we have only 1 carbon. Therefore they aren't balanced. So the easiest thing to do is to just simply write a big 4 in front of my carbon there. And so I have 4 carbons here now, 4 carbons here now. So I can change this to a 4. Then I go to my hydrogens. And I can see on my reactant side, I have 10 hydrogens here. And if I look over here, my product side, I only have 2. So again, to get them equal, I can just simply put a 5 here, and any number that you put big in front, it goes all the way through the whole equation, and it would be multiplied by the little subscript numbers down here by this 2. So 5 times 2 is 10. So therefore my hydrogens are now balanced. Then I go to my oxygens. And I can see that I have 2 oxygens here, And I have, however, on my product side, I have 4 times 2 gives me 8. So 8. And I can see I have a 5 over here. So that gives me 5. And that's going to equal 13. Now to get 13 on my reactant side over here is pretty tough. Anything that I put into 2 doesn't work. Doesn't give me an equal a number that's similar. So usually one of the easiest things to do when you run into a problem like this is that you take that number that you have in front of water, and if it's odd, and you want to double it so it's even. So we're just going to erase that 5. So back to my H2O, and I'm going to put it as a 10. Now that's going to affect my hydrogens also, because we can see that before I had 10 and 10. Now, however, here my product side, oops, sorry, it's still on the eraser. On my product side, I have 10 times 2 is 20. Now, I need to have 20 in my reactant side, so the easiest thing to do to get 20 would be to put a big 2 in front of here. Now I have 20 and 20. If we go back to my carbons, though, that affects my carbons because I had 4 and 4 before, but now I have 2 times 4 gives me 8. So I'll scratch that out, and I have 8 now. But if I look over here, I only have 4, and that doesn't work. So I need to get rid of that 4, and the only thing I can do to equal 8 would be to put a big 8. So 8 carbons. Now my carbons are balanced. Now if I look at my oxygens here, I still have only 2 here, but if I look over my reactant side, I have 8 times 2 is 16, and I have 10 oxygens right here. So that equals 26, and that's an even number. Now this makes it a lot easier because I need to have 26 oxygens over here in my reactant side. And what will I get to get 26? I put a 13 here, and 13 times 2 gives me 26 oxygens. So now I have a nice balanced equation. I had to do a little erasing, but it worked out that now I have 8 carbons on my reactant side, 8 carbons on my product side, 20 hydrogens in my reactant side, 20 hydrogens in my product side, and 26 oxygens in my reactant side, and 16 plus 10 gives me 26 oxygens in my product side. Now we need to identify what type of reaction is this. So is it a formation reaction? Do I have 2 things becoming 1 or 3 things becoming 2? And no, I have 2 and 2. So not formation. Is it a decomposition reaction? Do I have 1 thing becoming 2 or 2 things becoming 3? No, it's not. I still have 2 and 2. Is it a hydrocarbon combustion where I have a carbon and a hydrogen together, just like I do here, plus an oxygen gas, yield me the products of carbon dioxide and water? And that's exactly what I have here. I have my hydrocarbon, which is butane. I have my oxygen gas, and these are yielding me or producing carbon dioxide and water. So therefore, this reaction is a hydrocarbon combustion reaction. So there's another example. We've already talked about the formation, the decomposition, where there's videos on the single replacement and double replacement. So hopefully you're able to learn something here about identifying all the molecular compounds within this, writing it out in chemical formula, balancing it, and identifying what type of reaction it is. Thanks a lot.
Made with Doodlecast Pro.